Group 4 project by
pH.
Vanessa
The wrong
Bors,
data
Akeisha
table.
Myers, Haley Rotier, Claudia Shabe, and John Michael
I
Jim.
guess so. I think he was going to do pH.
This table shows the data collected at the Plover River. The first 4 trials show data collected in one area of the river, whereas trials 5 through 8 and 9 through 12 show 2 additional spots where data was collected. This table shows the data collected from hot tub water. Some noticeable changes from the Plover River data table is that the temperature is higher and the dissolved oxygen is lower. There's also no numbers for the NH3 because it was off the scales due to its dark orange color.
Yeah, it's fine. I'll do it.
Dissolved oxygen. What is it? Dissolved oxygen, aka DO, is the amount of gaseous oxygen that is dissolved in aqueous solution. DO gets into water by aeration, known as rapid movement, and diffusion from the surrounding air, and by being a product of photosynthesis. It is the limiting factor in aquatic ecosystems, and it is expressed as milligrams of oxygen per liter of water, as seen in the tables. Physical factors that influence DO. The first one is temperature. Warmer water has less dissolved oxygen because at higher temperatures oxygen is less soluble. Gases like oxygen dissolve more easily in cooler water versus warmer water. Salinity. This reduces solubility of oxygen in water. This is typically disregarded in Wisconsin streams because of the low salinity values. The third physical factor is stream structure. DO concentrations usually decrease between surface and bottom measurements because there's less surface interaction between air and water in deep sections of a stream.
So then tonight I can.
Biological factors that influence DO. Photosynthesis. When aquatic plants photosynthesize, large amounts of DO are given off during the daylight. Respiration. Respiration from algae, aquatic vegetation, and microorganisms consume oxygen all day and night. The last biological factor that influences DO is BOD, which is also known as biochemical oxygen demand. This is an important factor that affects the concentrations of DO in streams. It is the amount of oxygen consumed by microbial decomposition of organic waste. It is measured by change of DO in a sealed water sample over 5 days. High levels of pollution can increase BOD in a stream. Healthy streams have BOD readings of less than 2 milligrams per liter. Climate also has an effect on DO. Dry climate equals higher temps and less water flow, which equals low DO levels. Wet climate equals cooler temps and more water flow, which equals higher DO levels. Since the hot tub water is also hot and has the same consistent volume of water, this gives us the low constant DO levels when testing the hot tub water. How does dissolved oxygen affect the environment? Dissolved oxygen affects what types of organisms are present in a stream and regulates some nutrients in the water. Many fish and microinvertebrates are sensitive to low DO levels, which is why if you are testing in any water that has aquatic life, you will have higher DO levels. This is seen when comparing the river water data to the hot tub water data. DO levels are higher in the river water because there are organisms that need DO in order to live. If DO levels are too low in a river, it can result in fish and other organisms being killed. DO is directly related to pH levels. Low dissolved oxygen levels equals low pH levels. Also, shortage of DO equals the sign of pollution in water. Some extra things that you should know about dissolved oxygen are some numbers that are related to it. DO levels below 3 ppm, which is parts per million, are lethal for most aquatic species. DO levels of at least 6 ppm are healthy for most species of fish. DO levels of 1 ppm correspond to 0.001 grams of oxygen per liter of water.